Hello YouTubers, and welcome to this series on how to use a multimeter for beginners. Now in this series what I'd like to do is obviously show you the basics of how to take electric and electronic measurements with a multimeter. I'd also like to draw some nice analogies explaining the basics of how electricity works. So it's not just a kind of parrot fashion, this is how you measure voltage and this is how you measure current. Hopefully you'll get a better understanding of what you are measuring and how electricity works. I also want to cover off some safety in terms of doing these measurements, because electricity can be dangerous. So that's the one thing I want to show we do cover off. I think there are a lot of videos on YouTube where people just start sticking the test probes of a multimeter into the mains plug to measure AC, and I think you have to be aware of what you're doing, because you can, for one, damage your equipment, two, you could short out your electricity and stop your electricity working in your house, and three, more importantly, you can damage and hurt yourself. So one needs to take care and just be aware of those kinds of issues. So first of all, again, I want to thank Comtest, who are the Southern Africa agents for Fluke, for providing me with this multimeter, which is very helpful because I think it's a nice, good entry-level multimeter to kind of do this demonstration with. I also then want to pose just a little quiz question which you guys can answer in the comments, and then I will come up with the answer in the next video in this series with an explanation. So my question to you is, which is more dangerous? AC power or DC power? I'm not going to add any more information than that. I'm keen for you to come up with an answer and perhaps some justification to your answer, and we'll go through the answers and see what's wrong and what's right and why. Anyway, let's jump into the series. Okay, so let's get started and have a look at the basic layout of a multimeter to just understand what the different buttons do and what have you, and then start to get an idea of how we can take measurements. Now, on this multimeter happens to be a Fluke 177. It's a true RMS multimeter. A multimeter like this is potentially a good entry point into doing basic electronics and electrical measurement. It has a hold feature, which is nice obviously for holding measurements that you take. You can capture min, max, it's an auto-ranging multimeter, which means you don't have to adjust for different ranges, but you can select a manual range if you want. And then you've got a key which basically selects a secondary function on your selection dial. More importantly, down here we can see, and I'll bring in for a little bit of a closer shot, you've got your plug points where you plug in your leads that you're going to take the measurements with. You'll always, for your measurements, have your black lead plugged into this common. And then you'll have, for the purposes of this exercise, as we're going to be doing voltage, you'll have your red lead plugged into this voltage point over here. Now, a point to note is that some multimeters, and I will just mention that obviously besides voltage you can obviously measure current, and most multimeters will have 4 plug points where you can do higher current measurements, i.e. up to like 10 amps, and then a smaller one where you measure milliamps. Some multimeters will only have 3 because they don't do the fine measurement on the current side, and then they'll have a layout like this. Other multimeters may share some of their current measurements in this voltage probe or connection point over here. Now that can be a little bit concerning, because if you make a mistake and have your multimeter selected to the wrong setting while you're measuring, let's say you want to measure voltage, but you have it selected to current, then potentially you're going to cause a short and you can hurt your multimeter. You can potentially cause all kinds of issues. So I would certainly say try and work with a multimeter that gives you separate plug points for your voltage and your current. That's something very important to note. Also, if you follow any of my videos on leads at all, I always recommend that you use the best quality test leads that you can. It really does make a difference. It makes life a lot easier. If you can get ones with silicone leads, that makes all the world of difference, because it means they don't get tangled that easily and they can handle higher current, and there's less risk of these starting to heat up and melt and what have you if you do make a mistake. So that's something to be wary of. So the name, as the name implies, a multimeter in essence is an instrument with multiple options or multiple measuring meters inside it. We are going to concentrate on voltage for this exercise, and in essence what I would like to explain what voltage is with a little analogy. So I'm going to get a little drawing and put it here and we'll go through that. Okay, so here I've drawn a very simple little diagram basically of, we've got a little tap and a garden hose pipe with water coming out the end of it, and then a larger pipe down here below. Now this analogy is basically to try and explain what voltage is and what current is in terms of electricity and their properties. We're going to do current as well, even though the measurement of current will be in the next video after this, because they obviously do relate and it gives you a good understanding of how electricity works. Now in essence, electricity kind of has the properties of water flowing in a hose pipe. Just like if you get electricity flowing in a piece of wire, that's what we're trying to explain here. Electricity flowing in a hose pipe. Now you'll know on a garden hose there are two properties which you may or may not be aware of. When you put your finger over the end of that hose, you're going to feel pressure. That water is going to build up pressure. So there are two properties with that water coming out. You've got pressure and then you've got a volume of water. Now the pressure, there's a direct correlation to voltage. Voltage, in essence, electricity flowing in a piece of wire, is like the pressure of the water in a water hose pipe. And in essence, what we do with what we're going to measure with a multimeter, the multimeter acts like a pressure gauge. In measuring water pressure, you'd have a little, let's say you tap in a pressure gauge into a pipe. In essence, that's what you do with a multimeter. You're just tapping into across a electrical component or a piece of wire to measure the pressure of electricity. And the pressure of electricity is voltage. So the other component of electricity is the volume, is the amount of electricity. And the amount of electricity correlates to current or amps. And there's obviously a very strong relationship between the two working together, which ultimately gives you power. Now we'll get onto that, I say, in a later video, but it's good to get a good understanding of those basics. And we're going to continue this analogy because it really is handy when we talk about resistance and all that kind of thing. It's far easier to visualize how those different properties work. So the one thing, when you're measuring voltage, it's one of the safer aspects to measure with your multimeter. There are certainly other tests like continuity tests, which we'll get into, which are relatively safe. But voltage, in essence, if you can imagine this we've got a big pipe with a large volume of water flowing through it, and it's got pressure. And let's pretend that it's actually under high pressure. If you just make a small hole in that metal pipe, even though it's a big pipe and there's a fair amount of pressure, potentially you can actually cork that with your finger or with a cork or what have you. Okay, so a multimeter can actually measure fairly high voltages relatively safely because of that same aspect with water flowing in a pipe. You just have to make a small hole, stick in a gauge and take a measurement. There are certain caveats to that, but basically that is the case. Things start to change, and I said we'll cover this in the next video when you get to measuring amps or current, because then you're having to measure the volume of flow going here, and that's where you have to have something in this flow And that's where things get far more interesting, because you're having to pass all of this flow through your multimeter, and that's when you can potentially start burning or melting things if you're not careful, depending on the limitations of your multimeter. Whereas voltage, we're just basically tapping into the electrical wire and measuring the pressure. Okay, so let's move on to how we do that. Okay, so let's get ready to connect our multimeter, the leads into our multimeter, to measure the voltage of this AA battery. Now, one important thing to note here is that, as you can see, we're just going to measure the voltage of this battery. There are no other electrical wires or electrical components connected, because we're just merely, in essence, measuring the pressure of electricity inside, or the potential electricity sitting inside this battery. That's very different again if you're measuring current, but as I said, what I'll just explain. On this picture, if you've got that hose pipe and you had to plug the end, or this big pipe and plug the end, so that there's no flow of water, you will still have pressure. Okay, and that's exactly how this battery is. You do not have to have a light bulb or some electrical component connected to measure the potential voltage, because just by merely plugging the end of a pipe, you are still going to be able to measure pressure. It's different for current, of course, because if you you can't measure the volume of electricity unless it's actually flowing, and that's where things get a little more complicated. You need to have some device or some electrical component using electricity to measure current. But that'll happen in the next video. We're concentrating on measuring voltage, where you don't need something connected. But something to note as well, your voltage pressure will obviously differ. If you do have something connected, the pressure is going to drop, and it's the same for electricity. What we measure in this battery now is with nothing connected, no load connected. But as soon as you connect something, the voltage potentially is going to be different, because you've got flow, and that potentially is then going to drop the pressure. Okay, so how do we go about measuring voltage? We've got our multimeter, it's switched off at the moment, we've got our test leads. We take the black one, which is the common, and we push it into the port labeled common. You can see on this multimeter, it's on the bottom right hand side. The banana plug simply pushes in there. Then we've got the other red plug that goes into the one with a V for voltage, and that plugs in simply like that. Then on the multimeter, we have to select the measurement option that we want to do. And on here we can see that we've got a voltage symbol, and I'll bring you in a little bit closer to see that. You've got a little voltage symbol with a squiggle on top. Now that voltage symbol is AC voltage, okay? And in a pen-light battery, it's not AC, it's DC, it's direct current. So you can see the other symbol on the top of the voltage there is the straight dash with the dots underneath, and that's the symbol for DC voltage. Now your multimeter might actually have just one voltage option which can sense AC or DC. So you'll have to keep an eye out for that. It differs from multimeter to multimeter, but on most multimeters you'll need to make that selection yourself. Now you'll see over here there's one for millivolts, and the rule of thumb is here, it's always best, obviously that's a smaller reading of voltage, it's always best to start with a larger reading first, and if that's too large, go down. Because in some cases, particularly when we come to measure current, if you have a large current and start on the smaller reading, you'll potentially blow a fuse in your multimeter or damage your multimeter. So always start with the larger reading first, and as well as if you have a manual ranging multimeter, you want to start with the larger range first and then move down. This one's auto ranging, so we can put it straight down into the voltage range. Now, as you note on this multimeter, it has come up and it's noted on here DC. So again, you need to note that because your multimeter might have various settings, and if you have the incorrect setting here, you're not going to get the right reading. Now, for the most part, that might not seem serious, but if you do have your multimeter on the wrong setting, you go and take a measurement of, let's say, particularly a high voltage, and you have a wrong reading, you might think that what you're taking a measurement of is safe or not live. You go and touch it, you could electrocute yourself. So it's something always to be wary about, is to make sure you do check that. You know, at best you're going to have a wrong reading and have a wrong calculation or what have you, but at worst it could result in a safety issue, so that you have to be wary about. So there we go, we've got our multimeter selected on DC volts, which is exactly what we want for this battery. Now we have a red and a black probe. Obviously the battery, it's fairly clear on this battery. On a AA battery, the top over here is the positive, and you can see the positive sign over there. The bottom is negative. Sometimes they label it, sometimes they don't, but we know the one end is positive. Our red is positive, so we can put that on there. And we put our black on the negative. Try and keep your fingers out the way, because they potentially can have an influence. Have your probes go straight onto those surfaces, and we can see the measurement there is 1.91 volts. 1.91 volts, and that's about right, for this is a rechargeable battery. It's 1.2 volts in essence, and that is showing us the potential pressure of the electricity in this battery, and that is how you measure voltage. It's very simple and straightforward. So I'll get a few other items that we can measure, and then we'll move on to measuring AC voltage, where we need to take a little more care. Okay, so here I've got a few other batteries. The batteries are obviously all DC, so we've got our multimeter on its setting, on its voltage setting, which is fine. Here I've got a 9-volt battery, and on a 9-volt battery, to note is that the bigger terminal on the top of the 9-volt battery is actually the negative. I don't know if you can see that in the video shot. It's noted on the plastic here, and then the smaller one is the positive, and that's very straightforward to measure. So again, our black goes to the negative, the red goes to the positive, and you'll see there we go, this battery, which is a rechargeable battery, is currently sitting at 8.81 volts. This multimeter, as you can see, has a little bar graph at the bottom which gives you some indication, but that's if you have a fluctuating voltage, but that we'll demonstrate a little later. But there you go, very straightforward, 8.81 volts. Now we'll move on to, this is a sealed lead acid battery. It is rated as a 12-volt battery, so there's a little more potential pressure or voltage sitting in this. And quite clearly on the top they've actually got red for the positive, they've got black for the negative. We will put our 2 probes on there, and there we can go see it's 12.92 volts. Now just a little understanding, so as you can see, although this is a 12-volt battery, it says 12.92. A little bit of education here. A 12-volt battery, and this relates to car batteries, alarm batteries and the like, they generally, their fully charged state actually sits around anywhere from 13.2 to 13.6 volts. When they're being charged, and it differs from the type of battery technology, but while they're being charged, they actually are charged up to around anywhere between 14.2 and 14.4 volts. And that's the pressure, in essence the water pressure you're trying to push back, or the electricity pressure you're trying to push back into the battery. And those figures can be really critical, and that's where having a multimeter can be really handy to make sure that if you're charging something, or that the state of charge of your battery is sitting at the right level. If this battery was sitting at dead on 12 volts and I needed to use it for something critical, I'd be a little bit worried, because it's getting close to the point where in essence it's empty, or the cells inside, the plates inside, will be damaged. A battery like this, once it gets below 12 volts, like 11.8, 11.5, really needs a recharge. A battery when it gets to like 10.8 volts is basically almost classed as dead. And you potentially can cause damage at that level. Now, what happens if I happen to turn the probes over and to put the red probe on the negative and the other one on the positive? You'll see I get the reading, but there's a little negative sign on the multimeter. And that's because the polarity has changed. Now, with DC voltage has a polarity, so you can have a positive and a negative side. Now, I'm not going to go into too much detail about that. I just want to bring it to your attention that if you are taking a measurement and you kind of want to be working on the positive end of things, if you see the negative there, then you realize that you have got your probes around the wrong way. Once you start getting into electronics, that acts as a diagnostic, and sometimes you actually want electronic value, you want negative values, but that's when you start getting into more advanced measurements. But just to make you aware that you can have negative readings, but if you're kind of measuring a battery, that might be a hint that you've got your probes round the wrong way. Okay, so now we're going to move on to measuring AC voltage. And what I've got here is a multi-plug strip, which I have plugged into the wall. Here in South Africa, our voltage is anywhere between 220 and 240. So if you do touch yourself or get a shock from that kind of voltage, you certainly do feel it. So be very careful. So this is the caveat for these kinds of measurements, and that's why I don't like jumping in and saying, oh, just stick your pair of probes into your mains outlet and do the measurement. If you do it incorrectly, you can potentially damage things in your house, trip the electricity in your house, or hurt yourself. So what I have here, I have this strip which is connected. I'm going to actually switch on the main switch, and in fact this point over here will be live. As you'll note, I've actually plugged in a little adapter here which allows European and US plug points, because it allows me easy access. They are covered. These plug points are in essence covered for safety, so this at least allows me to get in easily. Now on the multimeter, as I said before, we have to go and select the right selection to measure AC volts. On this multimeter, as I noted, I'll bring you in a little closer as we do this. There is the voltage with the AC symbol above it. On the multimeter, you'll actually see it's got the AC there. And it's defaulted, you'll see it's jumping around at the moment because it's default, it's auto range to millivolts, so it's kind of more sensitive around this range. But now we're ready to take the measurement. Now AC volts in essence doesn't have polarity, so it doesn't matter which way round you use your probes. There is, however, in AC a live and a neutral. The live is the main feed bringing in the electricity. The neutral in essence takes it away to allow continuity for the electricity, but again we're not going to go into too much detail here. It's literally about how you measure AC voltage. And again, all I can say is be careful. Do not allow your probe tips to touch each other when you take the measurement. Do not allow your fingers to be near these, because in this instance we're not measuring a low DC voltage, we're measuring a high AC voltage, and it will bite. I recently did this to myself and it's not pleasant. So even someone who's had a little bit of experience, it can happen very easily and it's not pleasant. Right, so what I'm going to do, I'm going to carefully insert these probes inside over here, and you'll see we've got a reading of close to 230 volts. I'm going to pull them out. I'll just come back a little bit so you can get a better view of how I stick those probes in, and you can see the measurement. So here we go. Note, just be I'm keeping the probes at an angle. I'm noting that I'm not going to cross them with each other in any way. My fingers, you've got these stop points here for safety. I prefer having my fingers even further up the probes. Okay, so we go in very carefully. I hold them there, and there you can see You can see whether whether a power outlet is live or not by noting the voltage. In the States, you'll expect to see 110, 120 volts there. Here in Europe, or in the UK and a lot of Europe, and here in South Africa, anything from 220 to 240. And now here, obviously, even though I've got nothing connected here, in the house I have electrical appliances running. So this is a voltage pressure related to what's running in the house. If you had to switch everything off in the house, you'll probably find that this goes higher because there isn't electricity flow, so in essence there ends up being a bit more pressure, potentially, but we're connected to the grid, so there's a lot of things which can vary things. But here it's also potentially a good diagnostic to make sure you are getting the right voltage. And again, in a later video I'll show you some features on this multimeter that allow you to potentially diagnose issues with your mains voltage. So next we'll move on to a little demonstration with a variable power supply and an LED, and what happens if too much voltage or pressure is applied. Okay, what I've done now, these two leads come from a variable power supply that I have, and that variable power supply puts out DC voltage, which I can vary. I've connected it up to an LED so that if I vary that voltage, you can see the LED comes on and it goes through various brightnesses. Now what we want to do here, we want to measure the voltage at which that LED comes on and it operates at. So what I've got, and this is a helpful tip, these little crocodile clips which you can get in most electronics or hobbyist shops are really handy for doing those kinds of measurements. If I want my hands free while I'm making a measurement, I can connect them up to the probe. It can be really difficult taking a measurement like that and trying to make a change on the variable power supply. So what we'll do here is on the LED, I'm going to connect that to that side. And of course I connect it to the red probe. And I'll put that down there. And I'll connect the black to the negative. And we'll connect obviously this other side of the black onto that. And we can see there we've already got a voltage reading of 1.8 volts. So let's just play around. There's two things I want to show you here on the multimeter which are of interest, and I'll bring in a little bit closer to see that. As you can see, we've got the LED which is coming on at different voltages. So let's try and catch what voltage it does come on at. I'm just going to try and eye things carefully from where I am. I can see it just coming on and giving a reasonable amount of illumination, so anywhere between 1.8 1.9 volts. And that's the pressure of the electricity that's required to illuminate this LED. Now, as you saw, now I'm varying the voltage, and the one other interesting thing to note about a multimeter like this, which has a bar graph at the bottom, you can see it can be difficult to actually get a voltage reading or to see what's going on, and that bar graph at the bottom can give you some indication of what's going on with the voltage, that it's fluctuating if you cannot see the figures on top there. We'll address some more advanced features of what you can do on a multimeter in terms of voltage measurement, I say in a later series where we do when we step beyond the beginner's range on this video series. So now the one thing I'm going to do here for fun, I'm going to step up the voltage. We're going to see how far we can take this LED. So I just have to switch off the output. I had something limiting the voltage coming out. I'm going to drop the voltage to around 1 volt, and I'm going to put it back on again. Right, wow, that LED has come on, and it's come on fairly bright, and you can see the voltage is around 2.2 volts. So let's take it further. I can see it getting brighter, 2.3. If you manage to push more power into that light, what's going to happen? Now the reason more power is not going into that light is because I've got a limit on the amount of the volume of electricity going in there. So I'm going to switch things off again. I'm going to switch off that limitation, and we're going to try it again, just as a fun demonstration. There we go, we've got our LED on, we've got that voltage pressure. I'm not going to limit the amount of electricity that can go in there, and let's see what happens. We go up, 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 3, 4 volts, 5 volts. I don't know if you can notice, but I can see the LED is actually going dimmer and it's flickering. 7 volts, and pop, it's gone out. So at 11 volt mark, let's come right back down on the voltage and see if it'll come back to life, and the answer is no. So I've gone and applied too much voltage to this LED, and now I've gone and blown it. And in essence, the LED is like a pressure vessel. It's like having a bottle where you try to force, you need a certain pressure for, let's say, that bottle or a balloon. A balloon might be a better example. You need a certain pressure for that balloon to inflate so that in essence it's doing its function, i.e. this LED providing light. But if you push too far beyond that pressure point, i.e. you up the voltage too much, what's going to happen to the balloon? It's going to burst. And in essence, that's what's happened to this LED light. We've applied too much voltage and it's in essence damaged the LED light. So that's one thing. That's where multimeters, obviously for measuring voltage, i.e. the pressure of electricity, are really helpful, because if you apply too much pressure to certain electrical components, they will fail. Anyway, that basically sums up the kind of basic beginner's guide on how to measure voltage and what voltage is about. I hope that's been useful. If it does, if you have questions after this tutorial, please do post them in the comments field. And what I ask you to do is also keep an eye on the comments, because I have some very clever folk following my videos, and if I've neglected to point something out, they will certainly make a comment. Or if I've made a mistake, they will point it out, and I'll certainly try and annotate to pick up those corrections. So keep an eye there, because potentially there will be good pearls of wisdom. Anyway, thanks very much for watching this first series. The next video in this series, we'll talk about current and how to measure current, and we'll pick it up from there. And if you think someone else may find value with this video, please do share it. I hope it is of value, and if you do like the videos, and please give them a thumbs up, because it certainly helps what I'm doing. Thanks very much for watching, and we'll catch you soon.